Hello. This is an example of a DC mesh analysis numerical problem of level 0. So let's get started. Um, it's asking us to write the mesh analysis equations for the circuit and then compute I naught. And I naught is at the top right there, pointing to the left. But first, let's determine how many equations we need to solve for the mesh currents. And to do so, we're going to count up the meshes, and I see I1 and I2. And in reality, there's also the outer mesh, but we're going to assume that's the ground node. So to determine how many equations, you take the total number of meshes minus the ground node. So that's just going to be 2. And there's no control variables, so that's going to be it. Now, first step, I always look for to see if there's any current source in the circuit, but I do not see one, so we're going to be using a lot of KVL here. So to start with I1 on the left with that mesh, we're going to compute the voltage across the 8 ohm resistor. And using Ohm's law, we know that's resistance times current. So that's going to be 8 times I1. And then we're going to add that with the voltage across the 8-volt voltage source. But we have to be careful here. We're moving in the clockwise direction, and if we follow that along that mesh, we're going to hit the positive terminal first and then the negative terminal. So we know that's going to be a positive 8. And then we're going to add that with the voltage across the 2 ohm resistor in perspective of the I1 current. And again, using Ohm's law, that is resistance times current. So it's going to be resistance of 2 times the current, which is going to be I1 minus I2, because they're going against each other in the middle there. Set all that equal to 0. And that's it for the first equation. Let's move on to analyzing the I2 mesh. Let's start with the 6 ohm resistor on the right. Using Ohm's law, we know the voltage across there is going to be 6 times I2. Now let's look at the 2 ohm resistor. Resistance times current again, it's going to be 2 times the current, which is going to be I2 minus I1, because we're in the perspective of I2 here. And finally, we're going to add that with the voltage across the 1 volt voltage source on the top. However, when we follow the I2 current, we hit the negative terminal of the 1 volt voltage source first, and then the positive terminal. So we know it's going to be a negative 1. Set all that equal to 0, and then click submit. Now we can input a matrix to solve for these mesh currents. Let's start with the first equation, and we're going to add up all the coefficients for I1. And I see 8 times I1 and then 2 times I1, so if you add those up, it's going to be 10. Now for I2, I see 2 times negative I1, so the coefficient for that would be negative 2. And now the only floating integer I see in there is 8. If we subtract 8 from both sides, we're going to get all that equal to negative 8. Now let's look at the second equation. Starting with I1, I only see 1 in there. It's going to be 2 times negative I1, so the coefficient for that would be negative 2. Now for I2, I see 6 times I2 and also 2 times I2. If you add those up, you get 8. And the only floating integer I see in there is the negative 1. If you add 1 to both sides, that whole equation would be equal to 1. Let's click submit. And I'm going to input this in my calculator and I'll let you know what I get. Alright, so after inputting that into my calculator, I found that I1 equals negative 31 over 38, and I2 equals negative 3 over 38. Let's click submit. Looks good. Now we have to write the equation for the SOT variable in terms of I1 and I2. The SOT variable is I0. So let's see where that is on the circuit. Again, it's on the top right. And it's on the outside. So we know it's going to be directly in terms of I2. And I2 is moving counterclockwise. And when it hits I0, it's moving in the opposite direction. So I0 is going to be equal to negative I2. Submit. Looks good. And now we just put in that value. Negative I2 is going to be equal to positive 0.07895, as we can see up here. Let's click submit. Perfect. Thanks for watching, and I hope this helps.